Hi, everyone, and welcome to this session. I am so happy to be here to talk with you about improving usability for Amazon EKS clusters. My name is Jesse Butler. I am a senior developer advocate in the container services team here at AWS. So just to cover a quick agenda, we're actually announcing a couple of features in this session. So we're going to talk about a new console for Amazon EKS, and we're also going to talk about some features that we've added to extend the lifecycle management capabilities with EKS add-ons. And throughout, we're going to talk about not only what we've just released, but also what's coming for both of those features in the near term. So I want to start quickly just by setting some context and talking about what Amazon EKS is. And it is, at its core, Kubernetes. It is a native Kubernetes experience in a native AWS service. So users actually can leverage an amazing ecosystem of open source software because it is Kubernetes. But because it's a managed service at AWS, we also can provide a ton of native and well-integrated solutions for your AWS cloud workflows and your workloads. So from the container services priorities, we have this statement. We consider user experience to be our top feature, understanding that simplicity is powerful. So if you look at the evolution of Amazon EKS, foundationally, it started with security, reliability, and availability being paramount principles. And we moved from a managed control plane, which offered all of these things, and removing the undifferentiated heavy lifting of creating clusters and managing their life cycles, we pushed the management and the lifecycle management features of the service into the data plane with managed node groups and with Fargate integration. And with add-ons, we're extending that one step further, a sort of a logical progression into looking at the lifecycle management of your operational software on your clusters. We're also looking at that usability and simplicity aspect, and with the new cluster, so visualizing your clusters, their resources, and their workloads all in the same place. So let's look at the console first. I'm really excited to talk about this and show this off. So basically what we've done is taken the console that we already had and we've integrated native Kubernetes object visualization with it. So you have a unified, intuitive connection between your Kubernetes clusters, the workloads and the objects within them, and your AWS cloud resources that comprise them. So there's new node views for Kubernetes, as well as intuitive workflows for looking at your Kubernetes workloads in the cluster. And so when you first go to the cluster, it's not going to look much different. So you just have a list of clusters. But clicking into one, you immediately see something new, where we have an overview of the cluster and the list of all of the nodes that are joined on this cluster. And at a glance, you can see the node names, the instance types, what node group they're part of, when they were created, and their status. Moving to the right, we see another new view, which is workloads. And this is the first step that we're taking in unifying the Kubernetes in-cluster objects with the views that you get in the console. So here you see workloads, which are in Kubernetes, all of the things that are representing the work you're doing or the applications you have. So deployments, pods, jobs, those types of objects are all going to be here. And you can select from them, and you can also select by namespace. And then the last view, or the last panel here, is configuration, which is basically the content of the console that you already know. So this is where you can add new compute resources or configure your logging, look at update histories. So basically, this is the stuff that we're already used to. So I think a really exciting part of this is the workload visualization. So let's dig into that a little bit. So what we've tried to do is curate a set of views and relevant workload info in context within the console. So the Kubernetes API, if you're familiar with it, is fairly flat by design. So tooling like kubectl does quite a bit of heavy lifting behind the scenes to roll those views up and make sense of them for you. And that's what the console is doing here for you. So you have intuitive and correlative views in an otherwise flat API, And we can actually bring that AWS resource context into it as well, which we'll talk about in a minute. So getting back at looking at the workspaces, the workloads, you can actually select into different namespaces. So you'll be able to see just the workloads that are in those particular namespaces. By default, you see everything you have access to. So this is important to talk about. So before we dig into actually looking at some of the workloads, I want to talk a little bit about how this works. So viewing cluster objects in the cluster from the console requires a new bridge between sort of AWS land and Kubernetes land. So there's a new IAM policy or permission to access the Kubernetes API, which is Access Kubernetes API. So that's sort of the glue that allows you in the console to access the API of your cluster. And so any roles in the cluster that are viewing the cluster are going to need that. But this also works in cooperation with the in-cluster RBAC authorization. So we have an auth table there in the form of a config map where you can bind AWS IAM credentials to roles or users to privileges within the cluster. So these work in combination so that a console user will only see what they have permission to see. So this is very much like the access that you already have to EKS as far as the configuration views and say using kubectl. So what you need to do is make sure that any console user that you want to have access to the Kubernetes cluster objects, that their credentials are in that auth map. And this will all be documented in the documentation. But the idea here is to give you a seamless, intuitive experience without any surprises. So the last thing we wanted is to, sort of expose in-cluster views to users that didn't otherwise already have them. So this should be a fairly seamless thing where you're already provisioning, IAM credentials for users to have access to in-cluster objects, and those are the same credentials that are going to be used in the console. So these two aspects work together. IAM in the console and the EKS service, and then the IAM bindings in the cluster with RBAC. So these work together to make sure that your users are seeing exactly what they should be able to see. So then getting back to workloads, you can dig into one of the namespaces, and here you see I have a couple of deployments in this namespace. What's great here is that you have these clickable aspects. So if you click into a deployment, you're going to actually see all of the information that's relevant to that deployment. So you're going to see the info, the current status, what namespace it's in, when it was created. You'll also see the pods that are running as part of that deployment. And that's also clickable, so you can get into that and get some pod information. You see conditions of the deployment, which is really great. So at a glance, you can see sort of the health of this deployment and how it's doing, what its state is, and you also have your labels and the list of pods there is clickable, as I said. So once you click into a pod, you'll have a similar view where you can actually see the info about that pod. So you see the status, when it was created. And what's really cool is that there's a node link there too to the node that this pod is scheduled on. So we'll talk about that more in a second. But you can see also there are two containers in this pod. So we have a Redis, like a sidecar cache, and then we have the service running, weather service. So you can open those drop downs and you can see all the information about those containers at a glance. So your image, your ports, what your environment variables are. So this is a really easy way to click through. As you can imagine, if you have a deployment that's unhealthy, you click in, you can get to the pod, you can look at the containers and actually quickly visualize what issues might be happening. So you can troubleshoot those specific containers really easily. And this is just the start, as I had said, of our journey to bring you better experiences around this stuff. So we have a lot of things in the roadmap coming. So immediately we're starting to work on services and ingress endpoints, having volumes and volume attachments, persistent volumes, or persistent volume claims. So we'll actually be rolling out more objects for these unified and integrated views as we move forward. one of the things I really like, because I'm more of an ops thinker, is the node details. So right now, when you click into a cluster, you get a list of your nodes and you can see their status. Clicking into any one of them, you can get into the node details. And this gives you, again, at a glance, sort of the information about that node, its runtime, the kernel version that's running, when it was created. And there is a link here as well to the EC2 instance, if it's EC2 backed, and also a link to the node group. And you can see quickly the resource allocation, the capacities and the allocation. So you can see what the total capacity is and then what's remaining to be allocated. And any conditions on the node are seen at a glance here too, as well as your labels and annotations. So I think one of the things that we really want to call out here is that we're building these sort of intuitive workflows for visualization. So as an example, in the node page, you have a link to the EC2 instance. So you can jump right out, and that is a deep link into your EC2 console, which will bring you right to the instance that's backing that node. And this is great because if you see the health is not ready, you can actually just click through and see what's going on with that instance and take action if you need to. But there's multiple paths to those resources. So as I said, when you're looking at a pod, you can see which node that pod is actually scheduled on. So again, if you click through into the node, you land on the Kubernetes node details, which then gives you this link through to the EC2 instance. So depending on what avenue you're sort of looking at issues, or you're trying to determine more information about something, you can get to these things in various ways. So one thing to note is if you're using Fargate instead of EC2, each of your Fargate pods will actually show up as a node in the list. And this might seem a little odd, but it's actually working as designed, right? If you think about how Fargate works, each pod has its own compute environment. So those are actually joined to the cluster as nodes. So this is totally expected. And you'll be able to actually see all of your Fargate pods as nodes on the overview page. And then that last view is the cluster configuration, which we're already familiar with. This is where you can take various administrative actions on your cluster. And you can look at manage node groups and your Fargate profile configurations, your logging management, your update history. All of that stuff is still in place and largely unchanged. It's just tucked under this configuration tab now. But as you see, there's also a new addition to the configuration view, which is for add-ons. And that's the next thing that I'd like to talk about. So we're also, in this session, introducing EKS Add-ons, which is a curated list of operational cluster software. So these components are built and tested to work together on EKS. And you can enable them during cluster creation or anytime later. They offer a single operation, enables and disables, but also updates. So this brings this managed lifecycle operations into view for your operational software in the cluster. You can also work with the add-ons interface to attach a specific IAM role. So by default, any add-ons will inherit from the node role, but you can actually define specific roles for your various add-ons. So add-ons does require a minimum Kubernetes version of 1.18 and an EKS platform version of 3, and I'll talk about why in just a few minutes. But I just want to underline that this is sort of the next step in the evolution of the lifecycle management that EKS offers. Again, kind of looking for any opportunity for us to offload some of that undifferentiated heavy lifting. So we have managed control plane, managing your cluster lifecycle. We've moved into the managed data plane, which is where your nodes are with managed node groups or with Fargate. And with this feature, we're moving on to helping you provision and manage the lifecycle of your operational software in the cluster. So if we look in the console and you click into add-ons, you'll see a list of currently enabled add-ons in your cluster. So here we have the VPC CNI, and it's active. We can see quickly the version and what service account role that it's using. And here we're inheriting it from the node. And this can be done, certain add-ons can be added during cluster creation. So when you're in the cluster creation panel in the console, you can simply select which version to install for the add-on or to enable a cluster creation. It's important to note here that because the cluster doesn't yet exist, by default, this add-on will inherit the node role, but later on you can update it and use an IAM role specific to the add-on. And then later on, at any point in time after the cluster is created, you can come into the console and go to add-ons and enable new add-ons. So you just click Add New, and you get a similar walkthrough and a set of drop-downs, except now, of course, you can select the IAM role that you want to choose. So one of the really great things about this, and the powerful features of add-ons, is the single operation update functionality. So you can actually do either a single operation update or just a role change, and it will actually push a change out to your cluster, and it will do a rolling update. So you won't have any outages for your applications or for the operational software that you're working with. And also across an update, your configuration customization is preserved. So you can optionally resolve conflicts in that or work on that the resolution yourself. But let's talk a little bit about how that works, just because I think this is important. So EKS Add-ons under the covers uses a new Kubernetes feature called server-side apply. And this is the reason that your Kubernetes cluster version needs to be 118 or newer. This is effectively two things. It's a new merging algorithm, as well as a tracking of field ownership and changes over time on the server side. So this results in better reporting of configuration conflicts and basically an improved conflict resolution path. So it's moving what was kubectl apply, or how kubectl apply works now. It's migrating that to a much more sophisticated procedure on the server. So add-ons use that under the covers for update operations. And so that's the reason that we have the minimum version of 118 required. But this does effectively mean that you can do add-ons and we can work through configuration conflicts, which means that you can make configuration customizations in your operational software and it'll be preserved over the course of an update. And so you can update at any point by just clicking in to edit, and then you can choose a new version, and optionally you can override the existing configuration if there are conflicts. And so under the covers, an update is happening, like I'd said, as a rolling deployment. So the Kubernetes objects are gracefully cycled to the new version, whether that's an update or actually if you're rolling back. And the add-on becomes active once it's enabled after, at its new version, once this rollout is complete. And so you can see that in the console. And you can edit add-ons at any time to modify their versions, like I'd said. But anything that's down rev will have a nice update now action. So this aligns well with the control plane updates and also with a managed node group, where if at any point there's an update available, you'll get an update now button. And that's also shown in the dash in a banner. So updates can be invoked from here as well. And as with all of the lifecycle management operations in EKS, there is a history tab where you can see over time the full update history of that particular add-on. And each update has detailed information around the version and the state and if any conflicts were resolved. So that's all in the console, but if you prefer to use the CLI, of course, support for add-ons is there too. So you can list, create, describe what are available, update add-ons all through the AWS CLI. And you could optionally provide a service account when you're doing this, or inherit from the node, and you can optionally override configuration. So the functionality is exactly the same in the console and in the CLI. And EKS Cuddle has also been updated to support this feature as well. So exactly the same sort of workflows with similar ability to override the configuration conflicts. And what's really great about EKS Cuddle is you have the ability to define your configuration in YAML, so you can do this sort of as infrastructure as code, and you can keep this in source control. And there's some nice added usability features here. So for example, if you select with OIDC as true, but you don't specify a policy, EKS Cuddle will actually create one for you that's suited for that add-on. So that takes a lot of the guesswork out of like how you need to set those up. This is a really nice feature. And just as I'd said before, we have a lot more work coming in this space. So VPC CNI is available now, but very soon we'll have a lot more coming in the add-ons library. So we'll basically have an entire curated set of really commonly used operational software, from core DNS and kubeproxy to some of the open source controllers we have, the load balancer controller and the app mesh controller. The Flux GitOps controller is something that's on our roadmap, as well as metric server, Prometheus, CloudWatch. So we have a lot of stuff coming here on the roadmap, and I think this is a really exciting feature. Again, extending sort of the control plane lifecycle management and the data plane lifecycle management now to your operational software. So when you're creating clusters, you can just pick the things you want, and when it's time to update, you can just click through or make an API call and make those updates. So I really hope that you find both of these features and the work around them will help a lot with using EKS, and either from operationally around managing the lifecycle of your operational software, or just being part of the visualization with the new console as a developer or as an operator, being able to see clearly at a moment, just kind of clicking in and getting a picture of what's happening in your cluster. As always, this work is guided by you, our customers. So please do visit us on GitHub at our open source containers roadmap. Let us know what you think. If you like things, if you have some ideas for how we can improve things, we're always looking at that and using that to drive what next work is coming for us. So with that, thank you. I really appreciate you spending time with me, and I'm really excited about these features. That's my Twitter handle there. If you ever want to reach out, I'm happy to talk about these features or anything related to Kubernetes or EKS or AWS in general. Thanks so much.